Good morning or good afternoon, depending on where you are. My name is Professor Duke Orata. We are continuing with our lectures in thermodynamics. And today we want to look at other types of heat exchangers. We have already talked about parallel flow heat exchangers. We have already talked about counterflow heat exchangers. Today we are going to look at other types of heat exchangers. And fundamental to this is that you must remember that we obtain the expression for calculation of rate of heat transfer, we said was Q is U, A, beta Tm. And we got that mean temperature difference in our expressions where we had that delta Tm, mean temperature difference, was delta T at the inlet, divided by the natural logs of the two quantities. And so, basically in a nutshell, the rate of heat transfer, if you put in this quantity there, then would be UA into delta T naught minus delta Ti over natural log of delta T naught over delta Ti, where the I and the nodes represent the inlet and naught is the outlet. Don't forget, that's a fundamental expression which we got. And if I keep encouraging you to go through our lectures, we have discussed these things in detail in the other lectures. So we saw the parallel flow heat exchangers, and we also talked about the counter flow heat exchangers, and we came up with this expression. Then the other type of heat exchanger which we want to look at the cross flow. Heat exchanger. Now, diagrammatically, it's a very simple structure. Let's just draw. Don't worry, my lines might not be very straight. It's just for they are not drawn to scale. It's just for illustration purposes. But you can do a better job by drawing much more straight lines using your ruler and so forth. And so we have here the cold fluid. Let's call it cold fluid. And this is the exit. Of course, you remember the temperature profile. Now the temperature profile. This is the inlet temperature, which is uniform inlet temperature. Let's call it Ti inlet, and this is the outlet. Let's try to get it as best as we can. Outlet. And then we have, remember we said this is a cross flow heat exchanger. Then we have our uniform inlet temperature. Now we have the hot fluid. And of course the temperature profile. At the outlet. So we have temperature, inlet, outlet. Remember the I is for inlet and the O there is for the outlet. So this is an example of a cross flow heat exchanger. Now, this is now non-uniform outlet temperatures. So you can see the profile, the temperature profile in both cases. You can see the temperature profiles at the inlet and at the outlet. So this is a cross flow. So one, observe the temperature profile at the inlet and outlet. Very important. Look at the temperature profiles at the inlet and at the outlet. And we can say that for the cross-flow heat exchanger, it's kind of a hybrid between the parallel and the counterflow heat exchangers. The cross-flow heat exchanger can be considered as a hybrid between parallel and counterflow heat exchangers. And then, of course, if you look at it in terms of, if you look at the parallel flow heat exchanger and you look at the the counterflow heat exchanger and you look at the cross-flow heat exchanger, then you can clearly see that this is a little bit bulky. It's a bit bulky. It's not economic in size. The cross-flow heat exchanger is bulkier compared to the parallel and counter flow heat exchanger. So it's a little bit bulkier and not economic in size. But when it comes to laying ducts and piping, you find that it gives much more accessibility. So it's a much more preferred unit in piping, when we are laying ducts and piping. So we can just make a note that the cross-flow heat exchanger is bulkier. So not economic. Size, but is preferred. During laying of ducts and piping, as it provides a more accessible environment. So yes, it is bulky, but when you are laying pipes, when you are laying ducts and doing piping, you find that it allows more convenience in terms of accessibility as opposed to others. Now, the other type of heat exchanger which you want to look at is called is the shell type heat exchanger. Shell type heat exchanger. Let's just draw a schematic of the shell type heat exchanger. It's a little bit cumbersome, but we'll try to draw it for illustration purposes as best as we can. So this is just for illustration purposes. It's not the best, but it serves the purpose. And like I said, the lines are not the most straight, but you can do a better job. Do a better job. So let's have that. cumbersome. Bear with me. It's a bit cumbersome. Yes, let's try it again. I've taken too many big leaps. Yes, this is much better. Yep. So we have that. So we have that there. So this is the shell type heat exchanger. And we can refer to it as a mixed flow heat exchanger. We refer to as a mixed flow heat exchanger. And so you can see that it has both parallel cross flow, parallel cross and counter flow in one unit there. You can see that we are both, they are all merged in this particular system. We have parallel flow, we have counter flow, and we have cross flow. So note that we have parallel, counter, and cross flow. Now, these heat exchangers, which we have been talking about, are also referred to as recuperators. Why do we talk of them as recuperators? They're recuperators because basically the flow, the heat flow is steady and is continuous. These heat exchangers are also referred to as recuperators. And this is because the heat flow is steady and continuous. The heat flow is steady and is continuous. So what does that mean? It means that there are certain type of heat exchangers where the heat flow is not continuous. So we can think of the heat flow as being intermittent. It's intermittent. It's like, for example, when we talked about the internal combustion engine, if you look at the distributor of a vehicle, as you're setting the timing, you can always see those intermittent currents when there is contact between the points. Those are the lectures which you can look at with the internal combustion engine. So that's intermittent flow of current. So those kind of heat exchangers, we have intermittent flow of current, are referred to as regenerators. So regenerators are heat exchangers where there is intermittent flow of current. In other words, the flow of current, unlike in the recuperators, which is steady and constant, flow of current, of heat, not current. I talked about the distributor and thought about current, flow of heat. So in other words, it breaks on. And how is this achieved? In these regenerators, this type of heat exchangers, we have a metal matrix which rotates. So it gets in contact with the hot fluid and cold fluid alternately. In this type of heat exchangers, we have metal matrix. We have a rotating metal matrix. We have a rotating metal matrix contacting the hot and cold fluids alternately. So that if you look that type of a system, you have a metal matrix. Let's do that metal matrix. You have a metal matrix. Let's just shade it like that. So we have a metal matrix and it is rotating. I think this I've not drawn it to scale. It's just for illustration purposes. It's rotating. It's rotating that metal matrix. We have a metal matrix. It's rotating. And so we have the cold fluid, hot fluid, and we have the cold fluid. And of course they're separated. There's a seal here which separates them. The hot and cold fluids are separated. So that you can see the hot fluid is in the top chamber and the cold fluid is in the bottom chamber. So basically the temperature profile, hot fluid here, again I and O represent inlet and outlet, and for this particular one here also, the temperature profile, the inlet, the outlet, because that is the T, that's the temperature. So that's basically the temperature profile. So we have this metal matrix which rotates and it alternately gets in contact with the cold and hot units which you have talked about, the fluid, cold and hot fluids. And so this is a regenerator. In other words, the heat flow is intermittent. So it's very important what you have seen. We have seen the various types of heat exchangers. We have seen the parallel flow heat exchanger, the counter flow heat exchanger. We have seen the cross flow heat exchanger. We have seen the shell type heat exchanger, which is a mixed flow heat exchanger. And we have seen that they are classified in two groups, recuperators and regenerators. And the regenerators are where the heat flow is intermittent. So let's stop at that point. We'll pick up from there next time.